Hello friends, I am Kanak Bhatia. I am BTech Mechanical Engineer. This is my second presentation on industrial trainings. This is about the functioning of effluent treatment and sewage treatment plants. We would discuss in detail about all the four stages of wastewater treatment and getting its properties as per the CPCB standard. Now the next slides will be presented to you by Mr. Amit Bhatia. Before we start the slideshow, I would like to tell you the sequence of this training presentation. It would consist of explanation of the functioning of a common ETP or STP with a simulation model, flowchart of a common ETP/STP with capacities, detail of all the four stages of water treatment, basic parameters recommended by Central Pollution Control Board, the video showing a simple arrangement for treatment of household use water. Conclusion. Note: basic difference between effluent incoming water to the sewage incoming water is that in effluent the pH of water is disturbed and it may have oil traces and heavy metal particles in it. However, in sewage water the pH is generally neutral and there is almost absence of heavy metal particles and oil.
Hello friends. First of all, we would show you the simulation model for the working of a common effluent treatment plant or a sewage treatment plant. As you can see at the bottom left, the effluent water or the sewer water first accumulates in the collection tank. And as a first operation, we stir the collected water in this tank either with the help of bubbles created by a compressed air in case of a big collection tank, or with a stirrer in case of a small, maybe up to 50 kL collection tank. The idea is to have a homogeneous solution before we start any treatment. As you can see from here, the collected water is pumped into the chemical dosing tank. In the chemical dosing tank, we first do the mechanical treatment. This has two parts. First, we create a baffle wall at the center of the dosing tank to separate the oil contents, if any, present in the effluent and stop it from going further in the system. Then here we may install an oil skimmer at the entry side of the dosing tank where the oil can be extracted and collected separately outside. In the second half of the dosing tank, where now we have the oil-free effluent, we do the chemical dosing. The chemical may be stored in the containers at a height so that they may be fed by gravity. The details of the chemical treatment would be discussed later. From here, from the chemical dosing tank, the effluent water is fed into the primary clarificator tank. In this tank, we have a motorized fast stirrer which helps in settling down the coagulation at the bottom of the tank, from where the heavy concentrated effluent is sent to the sludge drying beds, and the clear water from the top of the tank is fed into the next stage of the area, that is aeration tank. In the aeration tank, we do the biological treatment. In the biological treatment, the idea is to decompose the bacteria and other microbiological substances present in the effluent faster by speeding up their life cycle. This is done through aeration and by feeding in yeast and maybe a little bit of alcohol. These two substances work as catalysts for the decomposition. In this operation, the decomposed bacteria and other microbiological substances precipitate in the water. This water is then fed into the next stage of treatment, which is secondary clarificator. In this secondary clarificator, again we have a stirrer, but this one is comparatively very slow since there is lesser sludge in the water now. From the bottom of the secondary clarificator also, we take the concentrated effluent to the sludge drying beds, wherein the sludge is dried. It can be sent to accredited, certified agencies who do the further treatment and decomposition of the sludge. and the residual water then can again from the sludge drying beds be fed into the first stage of the treatment, that is collection tank. Now from this tank we then send the treated water, clean water, to the clean water tank. This water is good enough for the gardening purposes. However, to make it more usable, we may consider further treatment of this water, and that is tertiary treatment of or microinfiltration. To establish the vital parameters of the clean water, we need to do its regular testing. For pH and TDS, we can test the water sample daily. It will help us regulating the dosing of the chemicals at various stages of treatment. However, for the other vital parameters, we need to send the water sample to the certified labs at least once in a month, as is also defined in India in the water and air consents which we get from the Pollution Control Department. The simulation being shown here does not talk about the sizes of various tanks being used for the treatment plant, but to have a fair idea of the sizes, we would show you the next slide, that is a flow chart of a working effluent treatment plant in a factory, which has the capacities of each stages clearly mentioned. So it will help you and give you a fair idea of the sizes also. Now we take you to the further training slide, which consists of the process flow chart for a paint shop ETP having a treatment capacity of roughly 10 KL effluent water daily. And this will give you a fair good idea about the slides which you had seen earlier. For the simulation of the ETP or STP, you'll have a fair good idea about the capacities of collection tank, dosing tank, and clariflucators and other aeration and clear water tank. So you will have a fair idea about the sizes and the kind of space required to set up an ETP or an STP in your organization. So you can see in this flow chart, process flow chart, the first stage is the effluent is pumped or brought by gravity to the collection tank, which in this case is 3.55 lakh liter capacity or 355 KL capacity. And from the collection tank, in collection tank we got an aeration, and as we had seen in the simulation site, and in this we do the aeration, or we can put a stirrer if the collection tank is small capacity, to make an homogeneous solution, because you got suspended solids and you got dissolved solids also. You got oil also, you could be having oil also in the effluent. So to have an homogeneous solution for before treatment, you need to stir it or through a stirrer or through bubbles generated by the compressed air. From the collection tank, the effluent is then pumped to the dosing tank, which is an oil and grease trap tank also. Here the treatment, this is the first stage of treatment where we do the chemical treatment. We do the chemical dosing here, and the mechanical trap is there. We can put a oil skimmer also in this tank. This is having a capacity of 6,000 liters or 6 KL. From here, after dosing the chemicals in sufficient quantity, we send the effluent to the primary clariflucator, wherein there is a conical chute at the bottom, and a stirrer, slow stirrer is there, which which helps the denser sludge, denser effluent collect at the bottom, and from the top we can have comparatively clearer water, since the precipitation and flocculation and coagulation has already taken place in this tank. So from the top surface, we comparatively clearer water, we send it to the aeration tank, which is in this case around 13 KL capacity. In this aeration tank, we do the biological treatment, which is again having two steps. One is the aeration or stirring. Through aeration we can speed up the biodegradable activity, and by putting further secondary we can put in catalyst like yeast and coal or any other substance which stimulates the bacteria to have a faster life cycle, and becomes neutralized. From the aeration tank, then the comparatively clearer water is pushed to secondary clarificator, which again in this case is 13 kL capacity. Again at the bottom there is a conical chute, and from primary and secondary both clarificators, from the bottom conical chutes, we comparatively denser effluent which is collected at the bottom, we connect it to the sludge drying beds, from where the dry sludge from the top surface is collected and put in the leak-proof sealed bags, maybe HDPE bags or containers, to send it to the certified government CPCB or State Pollution Control Board certified recyclers. And at the bottom we can put again a pipe, to get the residual water back to the collection tank, which is the first stage of effluent or sewage treatment plant. So from secondary clarificator, we push the water to the clear water tank, which is comparatively very clean. This in this case is having 36 kL capacity. From here, if we are not attempting to make this water potable, we can directly use it for plantation or reuse in any of the utilities in our factory organization, or we can put it in the stormwater drain also, in case, of course, the water parameters are within the compliance norms of the CPCB or State Pollution Control Board. But if we want to make the water potable, then we have to have the fourth stage of water treatment, which is tertiary treatment, which consists of various wire mesh or porous big filters, which may be ranging from 200 microns to maybe 10 microns stage wise. We can then have the treated water tank installed after the tertiary treatment, wherein we can collect the treated water and reuse it for plantation, our canteen utility, utensils washing, or reuse in any of the factory utilities, or we can put it in the drain also. In case we are putting this water for the plantation, irrespective of whether we are checking the norms daily of the clean water from ETP or STP, we must get a periodical testing of the soil also, wherein we are sending this water for plantation. Well, this is a slide which shows the basics of sewage and effluent treatment, water treatment plant, wherein water treatment primarily consists of 4 stages of treatment, and these are: number 1, mechanical treatment. This consists of another 3 sub-steps, that is aeration in the effluent water collection tank for homogenization of the solution. It could be having a stirrer also in case the tank is, as we had discussed earlier, in case the tank is smaller, and a wire mesh filtration to stop major dust particles and debris from going ahead for the dosing tank, and then separation of the oil content using oil skimmer, and a tank consisting of baffle valve, which is the dosing or oil trap tank. It traps the oil at one side only because of the bottom baffle valve, and wherein we can put the oil skimmer to get this oil out of our system. Then the second stage is the chemical treatment. This consists of dosing, lime, polyelectrolyte, alum to get the flocks, and ultimately coagulation and of the impurities in the water. Of course, other than these 3 major chemicals, acid can also be used in rare cases in case the pH of the water is very high. Then with the acid we need to reduce the pH to around 7, and then again with lime we need to increase its pH, since it's evident from experiment that flocculation and coagulation is better in alkalinity, especially when alum is used for coagulation. You can say it's better in alkalinity, or you can also say that it absorbs certain amount of alkalinity of water. So if effluent is safely around 8.59, it will bring it down to around 7.5 once the coagulation takes place automatically. You need to make the effluent slightly alkaline to get the better results. And we had discussed earlier what is the difference between the sewage water and the effluent water coming from a factory or sewage from the toilets. Primarily, the sewage doesn't consist of the heavy metal contents or oil, and wherein the effluent may contain both. Then the third stage comes biological treatment. This consists of doing aeration as well as adding catalysts like yeast and alcohol or any other such kind of catalyst to decompose the biodegradable substances, bacteria, etc. in the water by speeding up its life cycle. Then comes the fourth stage of treatment. This is tertiary treatment. This consists of micron filtration using column filters, or maybe if you want to make it very portable, you can go in for a industrial RO also, in case the capacity of the treatment plant is huge. Then I've given here lime. It's calcium hydroxide or calcium oxide. Is predominantly used to adjust pH, but as a softener, it can also be used as a coagulant aid. The lime bounds the other particles and increases the size or weight of the flocks, which then increases the speed with which they settle out of the water along with polyelectrolyte or alum. Lime must be added into water in an aqueous solution only, as it has a tendency of releasing a lot of heat once reacts with the water. So you need to take little precaution. The person putting the dosing chemicals into the dosing tank needs to